Oh man, I would not want to be that planet. Oh, hi there. Welcome to All Night with Dean Regas. Today I'm going to be talking about black holes. That's what this artist rendering is. Pretty sweet artist rendering. And there's a planet right there that's going to be swallowed up, totally destroyed. But we're going to be talking about what's going on inside black holes, because before just a few years ago, the only way we knew about them was, well, they're really hard to see in space. And so we couldn't tell any details, and it was theorized they were there, and then you could get artists to employ them to make really cool backgrounds like this. But then, just a few years ago, a massive undertaking by astronomers across the world linking telescopes got us an actual picture of a black hole. And this is so cool just for how we got it. I know it doesn't look quite as good as the artist rendering, but it's still pretty cool. And so I thought this week we would take a look inside black holes. Well, welcome to All Night with Dean Regas. I'm your host, Dean Regas. This is a show where we look at things in outer space and take a little closer look at stuff. And I gotta say, black holes are one of the most popular subjects that I come across. Everybody wants to know about black holes. Everybody's like fascinated by them. They are just totally crazy about them. Now, I gotta say something very controversial right here. And this is not gonna go very well with a lot of people. But up until recently, I was really bored with black holes. I was just like, I don't get the appeal. Like, yeah, there's a hole in space, it's black, you can't see it. I don't know, nobody knows what's going on inside of it. So when people would ask me questions about black holes, all I could say is, well, you know, they're like objects in space and stuff falls in and never comes out. The gravity's so intense, not even light can escape. But that's about all we could say. And even today, we can't really say much more than that. But it's like, you know, what's so exciting about it? And, you know, then there you got your movies, you know, like this one that, yeah, I think I saw it. I don't really remember it. All I really remember is the really sweet robot there. He was like terrifying robot. His name is Max or something like that. But check it out. It might be worth it. There's also a water slide called the Black Hole, but that's another point. But we want to get to the actual stuff of what's happening here with the black holes and where some of them come from. So, like I said, so black hole is an object in space with incredible density. So it's so dense that nothing can escape it. So on Earth, we can escape the gravity of the Earth if we can launch off of the Earth at, you know, 18,000 miles an hour. That's how we can break free of the gravity of the Earth. But to break free of the gravity of a black hole, you have to go faster than the speed of light. Nothing can go faster than the speed of light, so anything that falls in is gone. What happens to it? We don't know. But don't worry, we'll speculate later. It'll be a lot of fun. But now, where do black holes come from? That's also a question. So some black holes come from exploded stars, and so these would be on the smaller size of the black holes. So we've got kind of the stellar evolution cycle here. The top path is the path that our sun has taken over time, and we're about halfway through the path where we're going to end up being a planetary nebula. That's when the sun will kind of, well, not really die, but just kind of like change and all the planets will be destroyed. But that's like billions of years from now, so don't worry about that. We're going to focus on the bottom row here where we're talking the big stars. So massive stars, way bigger than our sun. What happens is we start with a lot more material. It's usually they're bluer stars or just bigger stars. They swell up to be red supergiant stars and then have some massive catastrophic explosion like a supernova happens. The remnants of that shrink down and collapse into a very dense core, and that's what gives us our black hole there at the end. So that's where most small black holes come from, at least as far as we can tell. And so this is another artist rendering. By the way, I love me artist renderings. I think this is great. Like it like takes me there. I'm like about to be sucked into the black hole. So, because we couldn't get an actual picture, definitely not with this kind of detail. But here's a black hole next to a sun-like star, and yeah, goodbye sun-like star after a little bit while. Now, in case you're wondering or worried about us, you know, like this happening to us, don't worry about it. This is the closest black hole to us that we've found. It's about 1,600 light years away. So that is incredible distance away, farther than almost all the stars you see in the night sky. So 1,600 light years is not something that's going to come our way. There could be other black holes closer to us. We haven't seen them yet. They are pretty hard to see because they're black and space is black and you can't see it very well. But it's not one of the things that astronomers are worried about, that a black hole is going to swallow us up. They are, by and large, very, very, very far away from us. And so this one's not anywhere near us. Now, then there's another type of black hole, and those are the ones that are supermassive, like way bigger than just a collapsed star. And we have one in the center of our Milky Way galaxy. By the way, artist rendering, not a real picture. We can't get a picture of our own galaxy because we're inside of it, but this is what we think our galaxy looks like. It's a pinwheel, a spiral galaxy, but it has a bar across the center. You might see that bar right there. That's a bar of stars. And at the very core of our galaxy lies a black hole. And its name is Sagittarius A star. Now, oh yeah, that was the wrong picture. But anyway, this is the picture of the galaxy. But we can't see the center of our galaxy very well because there's so many stars in the way, billions and billions of stars. So I wanted to show, this is another galaxy called the Sombrero Galaxy. But imagine that we are like somewhere along the edge here, and we want to look to the center of this galaxy. You have to look through lots and lots of dust lanes and lots of stars to get to the center of that galaxy. So that's what we're trying to do, is to look in our galaxy from one of those spiral arms into the center where the black hole is. Really, really tough. You just got too many stars in the way. It's like looking through a forest full of trees. You're gonna have stuff blocked. So initially, we can't look just with your normal telescope. You can't just like put your eye up to a telescope and see a black hole, but we could see it in a different wavelength. And so black holes give off X-rays. So this is the part that gets kind of weird, is because didn't I just say black holes swallow up everything and once they fall in, they don't come out? Yeah, but if it doesn't quite fall in, like let's say something's about to fall into a black hole and it misses, it accelerates to near the speed of light and gets ejected out. And so you can actually see the energy leaving the area of a black hole, not leaving the black hole, leaving the area of the black hole, and you can pick it up with special X-ray telescopes. And so this was a picture of the X-rays coming off of that massive black hole in the center of our galaxy called Sagittarius A star. Here's another one that's kind of showing this. So you look where the really brighter areas are, that's where the black hole is. So it's a picture of the stuff around the black hole, but not the black hole itself. How are we going to do that? Any ideas? We need some ideas. Oh wait, we got ideas. Let's find out. So it turns out that the first picture of a black hole is not the one that's closest to us. It's not the one that's in our own galaxy. It is in a galaxy far, far away. This is a galaxy called M87, and it looks totally different than the Milky Way. It's not a spiral galaxy. It is what's called an elliptical galaxy. It's just a whole big old mass of stars, like trillions of stars around a center. And so it has this big ball of light. And so M87 always kind of got our attention because pictures like this by the Hubble Space Telescope, we get stuff like this that's happening where you see like jets coming out of this. And so that bright ball of light, that's the whole galaxy, trillions and trillions of stars, and you get this jet sticking out of it. So this was captured by the Hubble telescope. This is the exact kind of stuff that was theorized that should be coming out of the area of a black hole that didn't quite fall in but sped up quite a bit. So this one became a cool candidate because if it's got such a big galaxy, maybe it has a gigantic black hole in the center. And lo and behold, that became the first black hole picture. So this is an actual photo, not in the optical wavelength, but still an actual photo of the hole with the gases around it. So this was huge because this galaxy is so far away and so massive that I was like, what? Why didn't they get one closer? But this was the one that they went for. And why it worked was because it was so big. So here is kind of a sample size. I'll get my head out of the way. So this is the black hole in the center of M87. By the way, it kind of needs a nickname. I don't know. We'll come up with something. But M87 black hole, you got to work on that. But to give you an idea of the size, that blue circle in the center, that blue circle is not the size of our sun. That is the orbit of Pluto. So we're talking about 8 billion miles from one side of that circle to the other. So if this was like in our sun, yeah, we would be well inside this black hole. And so this thing was humongous, especially, well, when you compare it to the other one. So we've only had 2 pictures of black holes to date. Hopefully we'll get some more soon. But this is the picture of the black hole in the center of our galaxy called Sagittarius A star. And if we want to compare them to each other, there is M87, again, needs a better name, and Sagittarius A star there. Huge difference. And so that's why we were able to capture this one first, because of its sheer size. So, question I get a lot is, well, where did these black holes come from? Nobody knows, because it's not from a collapsed star. A collapsed star cannot be that big to make these things. So this is getting astronomers and astrophysicists a lot of homework, that's for sure. A lot of people have questions for me when they hear I'm an astronomer, and they usually start a statement like this. They say, "Hey Dean, I heard about this thing in space. What can you tell me about it?" So, man, have I had a lot of "Hey Dean" questions about black holes, but I think the most popular question that I always get, it would be, "Hey Dean, what would happen if you fell into a black hole?" Well, short answer, I'd be dead. That'd be number one. But the falling in part is, I think, the part you're interested in, not so much the death part. And so if we wanted to pretend that there was a black hole somewhere around here that would just form into the studio and swallow up all the producers here and everything like that, you know, I guess it would get me first and you guys later. But let's say a black hole just appeared here. What would happen? Well, its gravity would be very intense. But the thing with black holes is their gravity doesn't reach too far, because the farther you are away from a mass, the force of gravity goes down very, very quickly. And also, black holes are small in size, so as long as you're just far enough away, you'll be okay. But let's say, well, you're real close, like that planet, and you're about to fall into the black hole. Well, this is bad news, that's for sure. So what would happen is, it depends. So if there's a black hole right here, and I wanted to fall in, I would say fall in feet first. Yeah, feet first. I mean, you want to see like the whole process as you're falling in. And so what would happen is, the closer you are to the black hole, the more you're going to be pulled. So your feet will be pulled more than your waist will be pulled more than your torso will be more pulled than your head, and you would end up stretching out. And so your whole body would stretch out. And eventually, if you take this to the longest extreme, your body would stretch out into a long strand of spaghetti. And this leads us to one of the best English words ever created. The process of falling into a black hole is called spaghettification. Definitely one of the coolest words. So that's what happens, the process of turning to spaghetti, as you fall into a black hole. Now, I also have to mention the downer physicist part about this is you wouldn't actually stretch into a piece of spaghetti that'd be like miles long. Your bones would break way before that. So your ankles would detach and your legs would detach and all that stuff. So it's not as glamorous as it sounds. So you would break up in all these pieces, but your feet would fall into the black hole, disappear, then your legs, then your torso, and then your head way on the outside is like, whoa, man, that was heavy, I'm going to a black hole. And then your head, black hole, dead. So, yeah, I guess that's kind of exciting. See, maybe I'm warming up to black holes. Maybe they are cool. Well, so that's it for this episode of All Night with Dean Regas. Thanks for staying up late with me and traveling inside a black hole. I didn't have a lot of answers for you as to like what happens inside there, other than you being dead spaghetti parts. But it's not like you're going to go to like, I don't know. I mean, people are like, do you go to a different dimension? Do you go to a different universe? I'm not, I don't know. It sounds fun and all, but I'm a romantic, so I just think you're crushed spaghetti in there. But, you know, that's just me. But we don't really know. That's the thing, because anything can happen inside of a black hole. Sounds like my neighborhood. Anything can happen. It's pretty good. So I hope you enjoyed this. If you like our shows, like us, subscribe, share it with lots of people. We'd love to have you spread the word on this. And we have a lot of fun with this, and we hope you do too. But get outside, do some stargazing, and thanks for staying up all night with me.